Hello, this is part 2 of the video series on protein secondary structure, and we're going to talk about beta sheets this time. My last one I talked about alpha helices, and they're perhaps even harder to visualize than beta sheets. With beta sheets, or beta strands, which are put together to make beta sheets, we have the polypeptide chain stretched out. So let's take a look at this. We've got an N, here's our alpha carbon, and here's our C double bond O. So this is the first amino acid. And then we have an N, and we have our alpha carbon and our C double bond O. So this is the second amino acid, etc. Notice that the R groups are alternating. Where are the peptide bonds? Let's do in green. Where are the peptide bonds? So we've got NCC and we've got NCC. So the peptide bond is right here. And remember, these four atoms are all in a plane because of the double bond character of the peptide bond. Yeah. So if we look at amino acid 1, notice that the R group is down. And if we look at amino acid 2, the R group is pointing up. And amino acid 3, the R group is pointing down. 4, it's up. So that's interesting. So you'll probably want to draw your beta strand like that. Also, remember we've got a trans-like shape here. So C double bond O, NH, they're trans to each other. Okay. So stretched out. So another way that you could write this as a cartoon is to say that it is like this. That's a beta strand. Okay, so we draw arrows for beta strands. And the beta strands always go from this is the N side to this is the C side. And you can tell there's the C double bond O, there's the N. So amino, there's the amino acid. There's the acid part, the C double bond O. But yeah, at the end you'd have another O there with a negative charge. At the end you'd have some more H's with a positive charge. Okay, so that is a small polypeptide. It wouldn't really, if this was in a protein, it would continue on. So you'd have another peptide bond here to another N, and you'd have another peptide bond here to the C double bond O, and there'd be another NCC, and here you'd have another NCC. Okay, so these strands can be put together to make what we call, I think I'll skip down here, you can put these strands together, and if you make connect 3 amino acids in there, you can do another strand. And I'm drawing these so that they are what we call anti-parallel. Anti-parallel beta pleated sheet. We can also have parallel, and that would be when the strands are all oriented in the same direction. So anti-parallel, they're opposite. There's, so how would you connect this? Somehow you'd have to have some other arrangement, maybe an alpha helix, to connect them. These would be connected by beta turns, or sometimes they're called hairpin turns, or loops, depending on how long they are. So, yeah. Maybe this is a loop. So this picture up here, which is figure 4.20. Oh no, it started to do that again. 4.20. Yeah, this is the structure of a reverse turn. So I wrote turn here. Sometimes it's called a reverse turn. And notice with the reverse turn, so here's, part of the beta strand here, and then it continues this way. There's 1, 2, 3, 4 amino acids that make that turn. And then also sometimes if it's not just a simple turn, we call it a loop of some sort. Okay, so here's a beta strand, another beta strand. Those are anti-parallel, right? They're pointing in the opposite direction. And where are the hydrogen bonds that are holding these together? So I'm going to get out my green pencil. Hydrogen bond, notice here's a NH and a C double bond O, so here's the hydrogen bond that's connecting. That holds this reverse turn in its shape. Now where are the hydrogen bonds here? They're between the strands. And if I draw them down here, okay, so there's a C double bond O, and here's an NH on the other one, and there's hydrogen bond between them. And then maybe, yeah. And we can do the same for, here's an NH, here's a C double bond O, and there's a hydrogen bond holding. And we'd have more than one of those. So maybe here's an NH, here's a C double bond O, and there's a hydrogen bond in between. Sorry, that's kind of small. Okay, so where are the hydrogen bonds in beta strands? Or what are beta strands held together by? Beta strands, beta pleated sheets, beta strands held together in parallel or anti-parallel by H bonds. And what are the H bonds? Same as with alpha helices. H bonds between the C double bond O and NH of the backbone. So not any hydrogen bonding between the R groups. This is the backbone. And remember that the R groups are pointing up and down, completely away from the backbone. So these are the carbonyl group and the NH group of the backbone. See, this is the backbone. That's what I mean by the carbonyl and the NH of the backbone. Okay, so there's some important bottom line information you need to know about how the secondary structure is held together.